Hi everyone, today I'm going to walk you through this hands-on lab validating AWS Lambda code using AWS Signer, available on QA platform, previously known as Cloud Academy. So I'll read through description of this lab and then start the lab. AWS Lambda code signing is the practice of digitally signing source code packages for functions and layers. The goal of code signing is to ensure that only trusted code runs in your AWS Lambda functions. AWS Signer is a fully managed code signing service that can be used to verify the integrity of your AWS Lambda code. Before your code is deployed, AWS Lambda will perform a series of validation checks which will determine whether to accept or reject the deployment package. In this lab, you will work in the AWS console to configure code signing for an AWS Lambda function using AWS Signer. This lab also covers the signature validation process in detail, including the validation checks and policies that can be applied to your code signing configurations. Learning objectives: upon completion of this intermediate level lab, you will be able to prepare an Amazon S3 bucket to store signed assets, create an AWS Signer signing profile, configure an AWS Lambda function code signing configuration, and initiate a signing job in AWS Signer. Intended audience are cloud architects, DevOps engineers, and software engineers. Prerequisites: familiarity with the following will be beneficial but is not required: Amazon Simple Storage Service, S3, AWS Lambda, and the following content can be used to fulfill the prerequisite: introduction to Amazon S3 and understanding AWS Lambda to run and scale your code. So environment before and environment after. That's all for the lab description. Now let's start the lab. As usual on this QA platform, this first step explains that we will be using a sandbox AWS account, so not a personal one, and this account will be available for 59 minutes to lab in. After that, the lab will be terminated. We can also end the lab anytime if we finish before official end of the lab, before these 59 minutes. And we can restart the lab, but with that new lab instance with new credentials, new details here on the left side panel will be available to us. So for now we see only cloud environment is ready, bridge is still not ready, but with this we can just log into our account, but let's not do anything hands-on because the lab infrastructure is probably not all spun up yet. Let's read through next step: configuring an Amazon S3 bucket to store signed assets. So the rest steps have validations in place. Great. Let's read through the step instruction until bridge is loading, and probably we'll read through the whole lab step. When we complete going through the instruction, then we will switch to hands-on part in the management console. So here the first step in the code signing process is to define Amazon S3 source and destination buckets. AWS Signer retrieves unsigned packages from the S3 source bucket, performs the signing job on the package, then deposits the signed package in the S3 destination bucket. In this lab step, you will enable versioning on an existing Amazon S3 bucket. To simplify this process, you will use the same S3 bucket to store both signed and unsigned packages organized into separate folders. In the AWS Management Console, in the search bar at the top, enter S3 and under Services, click the S3 result. The Amazon S3 console will load with the single pre-configured S3 bucket that you will use for this lab. Click the bucket name, Cloud Academy Labs lab bucket, begin. This empty bucket has been pre-configured to be publicly accessible for use in this lab environment. It will serve as both the source and destination bucket for your code signing process. Important. If you intend to implement code signing in your application, ensure that both source and destination buckets follow best practices and do not allow public access to their objects. From the bucket details page, click the Properties tab to begin updating the bucket configurations. On the Edit Bucket Versioning page, select Enable, then click Save Changes. Return to the Objects list by clicking the Objects tab. The unsigned assets will be stored at the root level of this S3 bucket. Signed code packages will be stored in a separate signed folder in this bucket. Click Create Folder, then below folder name enter Signed, then click Create Folder at the bottom of the form. Click this link to download a sample deployment package zip file. You will upload this unsigned deployment package to your S3 bucket. Back in the S3 console, click Upload. Click Add Files, then select the sample deployment package zip file you downloaded. Upload. With that, your versioned S3 bucket will now display the following structure: original unsigned deployment package zip file at the root, and an empty signed folder that will store your signed code packages. Summary: in this lab step, you enabled versioning on an Amazon S3 bucket, created a folder to store your signed assets, and uploaded a function code package. So let's start check. Now, just to try it out, we expect it to fail. Yeah, this check failed. Versioning has been enabled on the lab S3 bucket. It hasn't been enabled. Okay, we'll do that right now. So in S3, we'll use this bucket, starting with Cloud Academy Labs. Okay, we see the cloud environment and the bridge is both are ready. Okay, we have the console here, and see S3 we have already available in the bookmark tab. From the buckets we have only one here. That's the one we need available. And here no objects. So we have to first, there's the versioning in the lab step. We'll go to Properties, Bucket Versioning, we see it as disabled. But before that, let's see visual mode. Let's use the browser default. Yeah, I'm used to this look. I don't mind it right now. Bucket versioning disabled. Let's enable it. Okay. Here then we should download, right? The zip versioning done. Objects will create a folder called signed. Create a folder. Signed. Okay, and here we should upload the zip file. So my recording software won't show that part in the background. I'm downloading the zip. And I will now upload it. Okay, that's all for this lab step. Then we will rerun the verification check. So here, uploads. Let's add files. That should be it. Upload. Looks good. And let's verify. Great, validation passed. Let's proceed to the next lab step, configuring a signing profile and generate a signature. AWS Signer employs the use of signing profiles to sign your deployment packages. You can consider these profiles as code signing templates with predefined signature specifications. Signing profiles include a predefined set of instructions known as signing platforms that specify the following: signed file type, binary zip, signature format, and signing algorithms, hash and encryption. Note, although you cannot edit signing platforms, you are able to modify their implementation by using algorithm overrides in your signing profile. This process is outside the scope of this lab. A signing profile performs a signing job, which generates a signature and applies it to an unsigned zip file for Lambda to deploy. After a successful signing job, the package can be deployed successfully to a Lambda function with code signing enabled. To initiate a signing job, you must specify the source S3 bucket to retrieve the function code, a signing profile, and the destination S3 bucket to store your signed code. In this case, you will use the versioned S3 bucket you updated in the previous lab step. In this lab step, you will create a signing profile that will be used to sign your Lambda deployment packages. Then you will start your first signing job to prepare a signed deployment package for your Lambda function. In the AWS Management Console, in the search bar at the top, enter Signer, and under Services, click the AWS Signer result. The AWS Signer welcome page will load. Click Create Signing Profile to get started. Enter Lab Signing Profile for the profile name, then click Create Profile. We will keep the default signature validity period for this profile. After this period, all signatures generated by this signing profile will become invalid. Packages zip files that have been signed by this profile cannot be deployed by a Lambda function with code signing enabled. There are two possible actions that AWS will take if a signed signature is not available at the time of deployment, which will be covered in the next lab step. The signing profile details page displays an active profile status along with the profile ARN. In the next lab step, you will configure your Lambda function to trust this profile to perform signing jobs on your Lambda packages. We'll also notice the cancel profile and revoke profile actions available. Although you will be not performing either of the following in this lab, it's important to understand the differences between canceling and revoking a signing profile. If you cancel a signing profile, you cannot initiate a new signing job using this profile, but signing jobs in progress or that have been successful will remain valid until their validity period expires. Revoking a signing profile is a step above canceling, as it also revokes the signatures created by this profile. This causes all associated signing jobs to be untrusted, even if their validity period has not yet expired. Revocation also provides the ability to set an effective revocation start date to revoke this signing profile and associated jobs at a later date. Click Start Signing Job. On the Start Signing Job page, ensure the lab signing profile is selected under Signing Profile to use. Below Code Asset Source Location, click Browse S3 to locate your sample deployment package. Click Cloud Academy Labs lab bucket, then the sample deployment package zip file. Click Choose. Selecting this top-level key will inform AWS Signer to sign the latest version of this deployment package. For object version, select the only available version. This will likely reflect the current date. Below Signature Destination Path and Prefix, click Browse S3 once more, select the signed folder, then click Choose. Your signing job configuration will appear like the following, with the object version reflecting the current date. Click Start Job. The signing job has successfully completed and now has a signature status of active. Take note of the job ID value. Return to the Amazon S3 console, then click your lab bucket, Cloud Academy Labs lab bucket. Click the signed folder to view its contents. A new signed zip file has been created within this folder, matching the job ID of the signing job used to generate its signature. You'll also notice a difference between the signed and unsigned file sizes. Summary: in this lab step, you created a signing profile and signed your sample deployment package. So here we have two validations. We have to check them together at once. Okay, both failed. Check if an AWS Signer signing profile has been created. And the second one, check if an AWS Signer signing job has been performed. So both failed. Okay, let's perform this hands-on now. I'll create a new signing profile with this name. Let's put a signer in this bookmark tab. here we have to pick code asset source location and then signature destination path with prefix. And signature destination path with prefix. Let's start the job. Okay, it shows signing job status succeeded. And the job ID ends with 6F3D. Let's see, bucket we have bookmarked. So in bucket signed folder we expect to see a zip file ending with this name also. Check that. Looks good. Let's re-evaluate this lab step. Great. And the last lab step with 2 validations. We have 38 minutes left. Let's proceed. Configuring code signing for AWS Lambda. Code signing for AWS Lambda can be configured by attaching a code signing configuration to a function. Code signing configurations define the allowed signing profiles and the signature validation policy of your Lambda function. The signature validation policy defines what actions are performed when there is an attempt to deploy an unsigned package. The 2 available actions are warn. The function package is deployed, but a warning is issued. The warning is logged as an AWS CloudWatch metric and will appear in the associated AWS CloudTrail log. And second action is to enforce. A warning is issued and the function deployment is blocked. Code signing configurations can be enabled on new and existing Lambda functions. In this lab step, you will define an AWS Lambda code signing configuration and deploy a signed function package. So instructions are: first step to return to the S3 console. Before you deploy your Lambda function, you will retrieve the object URL of the signed deployment package. Navigate to the signed folder within your bucket. Click the signed zip package you created earlier to open its details page, then copy the object URL to a notepad or somewhere easily accessible. In the search bar at the top, enter Lambda and under Services, click the Lambda result. The AWS Lambda console will load. Click Create Function. Configure the following Lambda function properties, leaving default values if not specified below. Function name, enter lab function, runtime, select Python 3.9, expand the change default execution role section. Execution role, select use an existing role, select the Cloud Academy Labs Lambda execution role. This is a screenshot how that should look like in the management console. Expand the advanced settings section and configure the following properties to create a code signing configuration. Advanced settings, Enable code signing. Check this box to enable code signing. Code signing configuration. Select create new configuration. Description. Enter simple Lambda code signing. Signing profile version ARN. Select the lab signing profile version ARN from the drop-down menu. Signature validation policy for code. Select enforce. Code zip location. Ensure Amazon S3 is selected. Amazon S3 object. Enter the object URL of your signed zip package. Create function. Once your function is created, you'll be brought to the function details page. The code source section of the Lambda function no longer displays the inline code editor. As mentioned previously, code signing ensures the integrity of your function code cannot be altered or impacted by untrusted sources. To ensure this action, the AWS console, CLI, and API, the ability to create or update this Lambda function inline has been removed. The code properties section provides the profile and the job ARN used to generate a signature for this package. On the right hand side of the code source section, click the Upload from drop-down menu and select Amazon S3 location. You will attempt to update this Lambda function code using the original unsigned zipped package. Enter the S3 object URL below into the Amazon S3 link URL field, then click Save. This is the object URL of the original sample deployment package file you uploaded in the first lab step. The following error message will be displayed. Lambda cannot deploy the function. The function or layer might be signed using a signature that the client is not configured to accept. Going forward, this Lambda function will only accept deployment packages that have a valid signature that has been generated by the trusted signing profile depicted in the code properties section. With this code signing process in place, any subsequent function deployments will require a new signing job to generate a signature, thus ensuring only trusted code can be deployed to your AWS environments. Summary: in this lab step, defined an AWS Lambda code signing configuration and deployed a signed function package. By completing this lab, you have successfully performed the following tasks: configured an Amazon S3 bucket to store signed assets, created an AWS Signer signing profile, created a package signature using a signing job, and created a code signing configuration on a new Lambda function. So let's test the validations here, though we expect them to fail. First validation checks the desired number of Lambda functions. Check if the desired number of AWS Lambda functions have been created. There is a hint available. Did you create the desired number of Lambda functions? 1. And the second validation, configured a code signing configuration on a Lambda function. Check if a new Lambda function has been configured with a code signing configuration. Okay, let's go through this lab step hands-on. Okay, from the S3 bucket, let's get the object URLs for the signed and original package. So for the signed, here we can copy URL. It shows object URL copied. Okay, I'll store it in the background in my notepad. and let's copy URL for the unsigned zip. So in Lambda services, let's create a function and call it lab function. Lambda, we have it here bookmarked. Let's author it from scratch. Use Python 3.9. Change the default execution role, existing role. Let's enable code signing. Create a new configuration with this name. So here we should enter the Amazon S3 URL of a signed zip file. Let's get that from my notepad. Create a function. Successfully created the function, and it shows here in the code source section your function has signed code and can't be edited inline. On the right hand side of the code source section, let's test it out. Click the upload from drop down menu and select Amazon S3 location. Enter the S3 object URL of the original unsigned zip package. Click save, and we expect to see the following error message that won't save the updated configuration. And rerun these validation checks here. Let's paste this from our notepad. So we get the object URL for the unsigned zip. And we see the error as expected. Lambda cannot deploy the function. The functional layer might be signed using a signature that the client is not configured to accept. Let's cancel this, and that should be it for this lab. Let's rerun the validation checks. Great, all validations passed. So that's all for this video. Like and subscribe if you enjoyed this one. Until next video, bye for now.